Hello everyone. Today we're gonna have a look at the new programmer from XGecu or whatever way you pronounce it. I've got the new one from them, the T76, because I tried to program a NAND for a Samsung TV, which I've got in the shop here, and the programmer I had, this one, is still one of theirs. But is the TL8662 Plus one. I bought the adapter as well for it, and the problem was it wouldn't read this chip. This chip wasn't supported. The chip that I've got for this Samsung is I'll give you the exact name after. So I've got another programmer which is a very good programmer that I use for BIOS chips from Reveltronics, Revelprog. This is a very nice programmer, but unfortunately this wouldn't read that chip either, so I had to buy this one just because I got invested in this TV. Probably the TV is not worth it, but yeah, what the TV does is kind of boot loops. It starts and restarts continuously without actually being usable. You can't get into anything. It just tries to start and it switches off and starts again. So I got a new chip. I downloaded some the file necessary for it from the internet because I couldn't copy this one. Obviously, I'm gonna try to have a look, see if it's. But I presume this chip is not in good condition anymore, so I can't copy the software of it. But yeah, we're gonna try that file and let's see how it's gonna go. I thought I'd save you the unboxing, but unfortunately I should have done the unboxing because look, that pin is broken there. It was nicely wrapped, to be honest, but probably this was a bit too tightly wrapped, so it was protected and everything. The adapter seems to plug in, but also it's got this cable. I don't know if both of them need to go in or if it's optional, whichever way you want to use it. But anyway, we'll have a look at that. Let's try to fix this pin for the moment. Let's switch to the microscope. Okay, and that should make it usable. I downloaded the software for the programmer, and let's switch back to the overhead camera. Okay, so this one looks like these pins on the outside, they're not equal distance, so that means it will go in this way. Let's try to get it in. See where that pin fits. Okay. Alright, that's fitting nice. Maybe this back can go a bit more in. There you go. That looks in. Let's plug this cable in as well. Come on. That's in. I think they both need to go in together, because I don't think they would have supplied that cable if it wasn't needed. If this works nice and all that, I might put a link in the description where I bought it, and if anybody wants to buy this. But let's see, let's use the original cable so we don't have any kind of doubts about it. That's a bit short. If you reach it here. Don't think it's that important, the original cable, but hey. Okay. Turns on, so that's a good sign. Okay. Let me sort out the program a bit, and let's put this in. I'm gonna turn this off for a moment. This is the old chip that I'm gonna put in, see if it's okay. So the way this goes, that's the maximum I can zoom in. So pin number 1 is on that side, but because this is a 56 pin and the actual chip is a 48, the socket will take any of the 32, 40, 48, 56 pin nuns, but this is a universal one, but you have to align it this way, it says, and pin number 1 that side. So let's try to do that. I want to need a microscope to do this properly. Yeah, let me switch to the microscope. All right. Now, please. Yes, it's in. Nicely done. As you can see, we've got pin 1 mark there, and we also have a line to the bottom here. So that should be it. Let's switch back to the other view. Okay, let's try the auto identify. Well, it says this chip does not support it, so I selected it. Let's see if we can read it. Okay, the programmer read the chip, but unfortunately, as you can probably see now, verifying it, it gives loads of errors. So that was a bit of a waste of time. The programmer is quite fast. It only took a few minutes to read that chip. So okay, I guess while this keeps reading, it's time for us to take the chip from the board off. This is the new chip I put on the board. I tried to read and write with the old programmer, but yeah, I used a different chip name because it seemed to connect and all that, but yeah, it didn't work. So let's remove this chip. This is a new chip I bought, and I tried to put the software on with a different programmer. It didn't work. So let's unsolder it and see if we can do it with a new program. A quick switch to the other view, so you can see it shows there on doesn't get the mouse, but yeah, doesn't show the cursor, but yeah, it says there. Anyway, back to the microscope view. Let's remove the chip. Try to find different tweezers, but yeah. Okay. Alexa, turn the extractor on.
Okay.
I'm gonna try to remember to edit all this because somebody complained that messing with their Alexa at home, but right, board is all ready. Let's see what we can do with that chip. Okay. Switching back to the programmer. Switch it off and take that chip out. And put the... Let me clean this one a bit. We don't want to put all that in our brand new programmer. Let's make sure all the pins are clean. Don't want any solder short circuiting pin and all that. Got some funny bits of solder here. Any of the fluff. We don't solder, we don't flux. Nothing in there but the chip. Nice and clean. Don't even know if this chip is genuine, but there's one way of finding out. Alright, I just realized that chip doesn't look, because I couldn't see the circle there that shows that shows pin 1. Oh, there is there, I couldn't see it. Alright, never mind. Okay. It looked like a Mickey Mouse chip to me for a second, but yeah, the number 1 circle is marking is not very visible. Anyway, let's see if we can read it, and we'll take it from there. Maybe if we turn it on, it will help. Alexa, turn the extractor off.
Okay.
Okay, let's see if we can read this chip. Hopefully it's not fake, because all this programmer cost over £100. So okay, it seems to connect to it. I'm gonna stop reading it because it doesn't matter what's on it. I'll try to load the file and try to okay, we're loading the file. That file is 2 point something gigabytes. So 2.2 gig. Anyway, let's try to program it and see. I'm gonna let this run in real time so you guys get an idea how long it takes to program 2.2 gig or 2.3 gig. Not too bad. When I was using the older programmer, the older model from the same company, this one, it took ages to program, and obviously didn't work. But I was gonna try it anyway. I've slowed down a bit, but still is at 40% almost. Look at that. That's sped up. Is 83 now, 84%. Verifying it quite fast as well. Yeah, so it took a minute and a half to program it. And whatever's going to take to verify it, probably more or less the same time. Yeah, less. So 2 minutes altogether, roughly, to program and verify this. All we have to do now is to solder it and hope for the best. Let's solder it back onto that board. Get back to the board. There it is. Switch to the microscope again. Alright, nicely done. Okay, let's pull it down a bit. And let's clean and inspect it. Looks a bit on the edge, but yeah, that's fine. Flux is cleaning on. They're all good. Okay, more cleaning, and that's it. For the people that want to see the board version, right, the TV model is UE40D, okay, and the board model is BN41-01660. It's an older TV, but for some reason I just wanted to save it. I got into it and somebody actually gave it to me for free. They said, oh, you can have it if you can fix it. So I invested a bit of time in it, and once you get sucked into projects like this, if you're in this kind of business or hobby with electronics, sometimes you get over invested into projects that don't make financial sense, but it's not worth the money basically. But yeah, it's worth for the passion of electronic repairs and for for the satisfaction of getting a win. Maybe I'm talking a bit early. Maybe I'll put this in and it's not going to work, and this TV is going to end up in the bin anyway. But yeah, let's put it all together and I'll show you once it's inside the TV. We'll plug it in and see if it works. Okay guys, I put it roughly back together. Time for shaky cam. Let's turn the power supply on. Okay, this is the board. Board is there. Only put a couple of screws on. Alright, it turned on and it says check signal cable. Let's plug a HDMI cable in. Alright, it stays on. So far is good. Let me try to find a source that I can plug in here. Okay, I even managed to find a remote for it. Let's see. Source. Very dark, but we're gonna go into. Don't know if you can see there. Probably most of my. Okay, now we can see the microscope. Okay. Settings. Let's see if we can get a bit more. Alright. Get a bit more life into this screen, but yeah, it's all working. Presume if we go into the let's see if we can find the software. It's got picture in picture, this whole thing. Oh yeah, look at that. It has picture in picture. Right, we're going for the, sorry about the shaky cam guys, but and yeah, the flickering as well. I should have set up this hand camera anyway. I don't know whether okay, that's the current version, that's the file I had. Yeah, and I'm gonna try to see if there's any newer version that I can upgrade. But yeah, I'm not gonna keep you here any longer. Basically, this was a success, and maybe I'll do a comparison on speed between the programmers, between this newest T76 and RevelProg, which is my my favorite programmer. Alright, thank you very much for watching, and I'll see you on the next one.